Welcome to this brief introduction to containers and Docker. Let's get started at the beginning by answering the question, what is a container? A container image is a lightweight, standalone, executable package of a piece of software that includes everything needed to run it: code, runtime, system tools, system libraries, settings. Containers can be thought of as a next generation of virtual machines. They're self-sufficient units that can be shared between developers and a production environment. A container has everything within it to run the exact same way, regardless of which computer the container is running on. With virtual machines, each instance of a virtual machine requires all of the components of the guest operating system. This means that each VM requires a specified amount of RAM and storage space, and that is replicated over and over, even if the VM is doing nothing. Starting up a VM can take a couple of minutes, therefore they have to be running at all times to meet customer expectations. VMs run on a hypervisor, which also takes up its own resources. Containers have only the parts of the operating system that are absolutely necessary for them to operate correctly. This makes containers much more efficient. They don't run unnecessary resources in the background, don't take up idle space, and only run when necessary. Starting up a container is virtually instant, so containers can be stopped when demand is low and then generated when demand is high while still meeting customer expectations. Containers run on containerization software, which plays a similar role to a hypervisor. There are many different companies that develop containers. Docker is not an entirely unique technology, or even the first of its kind. However, since its release in 2014, Docker has exploded in popularity and is currently the most popular container in the IT industry. Other companies that have developed containers or similar technologies include LXC, which is Linux containers, Rocket, a security-minded standards-based container engine, Heroku, a cloud application platform, FreeBSD. Since the year 2000 and the release of FreeBSD 4, FreeBSD has had the concept called jails, which is similar enough to be considered in the list. And finally, the Data Center operating system also deploys containers. So, now that we've got an idea of what Docker is, how do we get started? Docker runs natively on Linux. In Windows and Mac, it needs a piece of software called a Docker machine or Docker Quick Start. This adds a small layer of complexity, but it's well worth the trouble. Installing Docker on Ubuntu 17.10 is a really easy task. Simply type sudo apt-get install docker io, and then start the service with sudo service docker start. Docker is this easy to install on Linux distros. Follow the link in the video description for your preferred distribution. After installing Docker, you can create your first simple container by typing sudo docker run ti for interactive terminal or terminal interactive, ubuntu bash. We'll have a demonstration of that in a couple moments. However, for now, notice that this container results in a scaled-back version of Ubuntu 16.04, with only the things that are absolutely necessary installed and running. In a moment, we'll compare the running processes of an Ubuntu host computer to the running processes of an Ubuntu container. So here's how the Docker workflow works. Typically, the starting point is from a publicly available image. The container is modified to meet your needs, stopped, and committed to serve as a starting point to build from. So we start a container from an image, which is usually downloaded from the internet. You change that container to suit your needs, adding software packages, custom code, whatever you or your organization requires. You stop the container and commit it as your own custom image. Initially, this resides on your local computer, but it can be stored in an online repository such as Docker Hub. From your custom container, you can create as many instances of the new custom container as is needed, so each developer can have their own copy of the environment. Multiple containers can reside on a server, so on. Each Docker container has its own networking capability. It's possible to open and close ports, sending information to and from containers. Docker containers can be created with Docker files, which are similar to bash scripts. Each line contains a new container from the product of the last line. This means you can build up a huge system of containers using a Docker file. Docker containers are environment agnostic. They only require that Docker is installed and don't care about the operating system. Containers will run the same anywhere and everywhere. So why do we use Docker or containers in general? Using Docker will make deploying and updating applications easier and faster. This means faster to market and better customer experience. Applications are more scalable using Docker because new instances of the software are instantly available. Unfortunately, orchestrating numerous containers may increase the complexity of applications, but the benefits outweigh the complexity added. Eliminating application reliance on virtual machines will save system resources. Instead of dedicated RAM not being used properly, containers use only what is actually necessary at the time. It is anticipated that most enterprise clients will already have Docker installed. The most important benefit of containers is that sections of code can be divided up and only used if the enterprise client needs them. This makes deployment much easier and scalable. As each aspect of the application being developed is separate, if there's a problem with one, the entire application need not fail. Finding and fixing bugs is easier, and sending patches to clients is easier because they're smaller. Finally, because containers are environment agnostic, there will not be any need to develop multiple versions of the software. There's no need to write software that will play nicely with other various software or hardware. If the target machine has Docker, the container will run the same as everywhere else. So let's do a quick demonstration of Docker. Before I begin showing you Docker, I just want to show you exactly how many processes are running on my computer at the moment. Okay, and that's not all of them, but you can see it's quite a lot, and it's changing. And I've got web content, Kazam, that's my capture software, Firefox, Xorg, Pulse Audio. You can see there's a ton of processes that are running in this Ubuntu machine. So I want to compare that. I want you to keep that in mind, and I'm going to show you how many are actually running in a Docker container. Okay, so I'll just clear my screen, and I'll show you that sudo docker images. This shows you how many images are on the computer. I've actually sort of reset this so that I have no images at all. I have no containers, just to show you how fast this runs even from the very, very start. Okay, so if I wanted to start a container, I would go sudo docker run ti, which is terminal interactive, and then I'll use Ubuntu because that's what I'm in right now, and but you can use CentOS, you can use there are literally millions of different containers that you can use. I'm just using this one because it's familiar to lots and lots of Linux users. And then the prompt I'd like to see is bash. So because I deleted all my images, it didn't have it within my computer, so it has to pull it down from a repository on the internet. And before I was even done telling you that, it pulled it down, and I'm running inside a container. It's 40 megs. I think the Ubuntu ISO is almost 2 gigs. So if you're going to run a VM of Ubuntu, you're looking at pulling down 2 gigs versus here it was 40 megs. I mean, it's crazy. If I do an ls, it shows most of the similar directories that are in the file structure of Ubuntu. But if you start drilling down into these, you're going to find that there's things missing, because this is just the shell, just the absolute minimum that is required in order for this to be a running instance. Okay, that's the whole beauty of containers. If I show you a top, remember I showed you that on my host machine. This is running 2 processes, bash, which we were interacting with, and the other one is top, which is the process that I'm showing you how many processes there are. So it doesn't normally run. It's just running right now to show you that there's only, well, really one thing running. So as you can see, it's pretty lightweight. Okay, now I'll just go back, I'll clear my screen, and I'll go back to a directory listing showing what's in here. The whole idea of Docker is that you want to be able to put things in containers, and then when you go reopen it, it's there. I mean, obviously you want to customize this environment and be able to share it with your developers, or share it with customers even. If it depends on what your application is. So if I were to create a file here, and I'll just call it my super cool file, doesn't matter, and then I do a directory listing, it's sitting there right on root. Okay, so I'm putting that there. It's just a marker to show that I've put some software on there. I've put some custom code in there. It could obviously be a real software package. It could obviously be a package of anything, really. It can be your own custom code. It can be, you can add apt packages from using Package Manager, and just sort of set up, this is my custom Python that I want to use, or this is my custom PHP I want to use, whatever it is that you're aiming at. But I've just done this sort of as a representative to show you that I've put something special inside this container. So if I were to exit this container, I'm back into my host machine. Okay, I'm going to do a listing of my containers now. So that's PSA. If you do PSL, that gives you the last container you used. PSA gives you all, even the stopped ones. So you can see that I've got a stop container. It's called Adoring Lalande, I guess. Docker does that. It puts these crazy names on them. And that's so that they're unique and you don't get them confused. So that container, that one container, has exactly what I'm looking for. It has my custom software, my super cool file. So how do I make it so that when I open up a container, it has the same thing? Well, if I were to run this command again and create Ubuntu Bash, I'll just go ahead and do that. Okay, it looks like I did the same thing. However, if I do a directory listing, my software is not there. My super cool file is not there. So where did it go? Well, you're starting from a starting image, and you started back where you started before. The custom thing that you created is gone. Okay, so here's how you make it so that it's there the next time you open it. So I'm going to exit that, and I'll do another listing of all of my containers. You'll see I have 2 containers now, Dreamy Synosy and Adoring Lalande. Now we know from before that Adoring Lalande was actually the container that had our custom software in there. So what we're going to do is we're going to commit it. So we're going to go sudo, let me just clear my screen so that it's easier to see. Sudo docker commit, I won't be able to spell Adoring Lalande. So let's just do a sudo docker PSA, and Adoring Lalande is the one we want. So sudo docker commit Adoring Lalande, and I'm going to commit it as my image. Okay, there you go. So I've committed it as my image. Now if I do a docker images, you'll see that I have Ubuntu and I have my image. Now if I had shown you that before, it would have only been Ubuntu on there. So my image is a new image that I just created, and it's custom. It has my custom software in there. So let me show you that it actually exists. So docker run my image. I definitely want it to be TI. And another command that's really cool that you can run is rm, which removes a container after you've used it. So if you are not wanting to make a change that is going to be preserved in the future, you can do rm, and that just cleans up. Because as you can see, just from this last 2 minutes of demonstration, Docker can make a mess of stop containers and images all over your computer. So you want to make sure you sort of keep against that, unless you've got oodles and oodles of storage space, and then you don't really care. So anyways, my image, and I want it to open in Bash. So here we go. It looks the exact same, but if I do a directory listing, my super cool file is there. So I've created a container that has custom software inside it, and I can open up as many instances of that container as I like. So that makes it so that I could distribute this to a colleague. I could use it several instances at the same time. The point is, it's very easy to share. It's very easy to move around, and this is sort of just the basics. You can actually create things called Docker files, which do make this process automatic for you. So you can literally give someone a 10-line file and say, spin this up, and they've got your custom image right there, as long as they have access to download the appropriate dependencies. So the idea is Docker makes everything easier from a deployment standpoint and a sharing standpoint. There is a little bit of extra maintenance that's required, a little bit of extra orchestration that's required, but the benefits are well worth it. Thank you.